So we have a pretty unconventional roof system on this project. The theory behind this whole roof system is that we're trying to allow it to dry to the outside. And at the same time, we're trying to put our control layers in a position where they can succeed to their strengths. So what we have is we have a TJI framed roof, which for a lot of people is unconventional, but has been growing in popularity over the last few years. That gets framed like a traditional raftered roof. Then we're putting 1/2-inch plywood on the underside of that roof. This is acting as our air barrier, number one. It's acting as our diaphragm strength for the roof plane. And then it's also acting as vapor modulation. So when we have moisture pushing from inside the house, it's slowing that moisture drive into the roof and insulation cavity, and vice versa if we ever have moisture driving in the other direction. And it's keeping that control layer in the warm area of the assembly, which means that it's got the longest lifespan. You know, we keep things dry and warm, they're gonna last longer than cold and wet. So we're setting that control layer up for success. Then we have 17.5 inches worth of cellulose that will be dense packed into there. You'll see in the assembly of this that we have 2x4s that were added on top of the eye joists to create essentially more meat for the fastening of the insulation on top of that, as well as to allow us to tie on our overhang lookouts and tails to create our eave and our fascias and our rakes on the project. Then we start stacking 60 millimeters or 2 3/8 inch worth of rigid wood fiber insulation on top of that. That just gets laid down, tongue and groove, goes together quickly. The joints in the field don't have to fall over framing because they're tongue and groove, so they can just land open in a cavity. So that means you can be really material efficient. You don't have to make cuts in order for things to land out. As long as they come together with a tongue and a groove, they can fall wherever you want. That gets applied to the whole roof deck. Then we put down 2x4s on the flat on top of that. And there's an engineered screw pattern from Rotoblas that gets followed, and that creates the tie, sandwiching that insulation to that TJI framing, creating some also of our shear strength in our assembly, but making sure that that whole assembly is clamped together nicely. That then gets topped with a traditional 5/8 roof sheathing. In this case, we're using zip because it allows us to dry in and protect the assembly quickly. And that cavity formed by those 2x4s now becomes our ventilation cavity. So we're always trying to create a way for moisture to escape. So what we've done is we have our vapor controlled on the inside of the building, slowing that moisture drive into the assembly. But now we are allowing it to go out through that wood fiber insulation, which is very vapor open. So that allows any moisture that gets into that assembly to pass up and out into this vent channel that we've created now and vented right from the eave up to the ridge of the roof structure. When we talk about the physics or the hygrothermal performance of a roof assembly, this is going to land you in the top echelon of how a roof's going to perform over its lifespan. And really we're going to these extremes or to these lengths for a couple of reasons. One, we're going to get great energy performance out of the house. We're going to have a very healthy house, but we're also going to have a house that stands the test of time and lasts really well. With these types of assemblies, it's very vapor open, you know, bio-based insulations that can deal with moisture. If there's ever any failures in the assembly and we have water or vapor or air leakage into them, they're set up in a position where they can manage that, they can handle that. Whereas if we have something else like a spray foam filled cavity, you get moisture into that, it's trapped, it has no way to dry out, and you end up having wood rot and decay and structural damage, and hopefully you catch it before it becomes a problem. So this not only gives us a well-performing house on the energy end, but it also gives us a house that's going to last longer.